So we have these two tables, city list 1 and city list 2. In city list 1, we have 10 cities: Jaipur, Pune, Mumbai, Chennai, New York, Little Rock, Dhaka, Taipei, Amsterdam, and Maastricht. In city list 2, we have these 9 cities: Jaipur, Pune, Mumbai, Chennai, New York, Lahore, Karachi, Kathmandu, and Colombo. Okay? Our aim is to find out the cities in city list 1 which are also in city list 2. Okay?
Okay.
So tell me those names: Jaipur, Pune, Mumbai, Chennai, and New York. Right?
Yes.
Jaipur, Pune, Mumbai, Chennai, and New York are in city list 1 as well as in city list 2. Right?
Mm-hmm. This is good. Yeah, this is main screen.
Let's suppose the name of this column is ID and this is city name. Similarly here, it is not necessary that the column name must also be same. So I can just call it the place.
Yeah, that's true.
So for now, my aim is to find out the city names in city list 1 which exist in place. So I'm writing down a query for achieving that. Select a dot city name from city list 1, city list 2, where a dot city name equal to b dot place. Okay,
Mm-hmm.
I can get this result using this, right?
Yeah. Mm-hmm.
So that's called inner join, as we already discussed.
Yeah.
Now let's look at the different scenario which you are facing. Right now, I am interested in all the city names which are there in city list 1 but not there in city list 2.
Mm-hmm.
So I am interested in these results.
Yes.
How can I achieve them? I am writing down a query for achieving them. Select city name from city list 1 where city name not in. Select place from city list 2. Now how can I achieve it using joins? I am writing another query for that. Select. This is achieving the same results using not in. Okay.
Okay. Mm-hmm.
Select city name from city list 1, comma, city list 2, where a dot city name equal to b dot city name. Outer join on a and sorry b dot place and a dot city name b dot city name is null. Mirza, if we will join these two tables, what is gonna be the result of left outer join? Let's say if b is not null, is not there, then this is gonna be the result. Okay.
Yes.
Now the values of b are gonna be returned corresponding to matching attributes. So these values will get returned. Now we are specifying another condition where b.place is null. So b.place
No.
is null in these cases.
Yes.
So
Those
that's
will
how
be
so that's
becoming
how
now.
that's how we got our desired result. You clear with it now, Moki? Hello.
Yeah, there should be another way to do that. I don't think
Yeah,
can it be distinct or something like this?
But in real time scenario, like I believe like inner join and left outer join are like use most of the time, right?
that's right.
Yeah.
Mirza, we only do left outer join when we want to keep one of the tables as master. Like in
Mm-hmm.
Informatica, whenever we want to keep our source as master, we use lookup.
Yes.
So what lookup
But
does is
but
it acts passively and it permits all the rows which are coming from source to pass through. And
yeah.
whenever they found a matching value corresponding to the joining attribute, it returns that value. And that's what we are interested in.
Yes. But when we show the data, like we show the details table first because it has a less row, right?
Sorry.
Less data.
Uh,
Like in I'm
so in ACID properties, first is atomicity. Atomicity states that a transaction must be treated as an atomic unit, means all or none. In consistency, you have already written down the example of balance match, means a database must remain in a consistent state after any transaction. अब इसका एग्जांपल देख लेते हैं. So this is account 1. This is account 2. I have zero balance in account 2 and $1,000 balance in account 1. Okay.
mm-hmm.
So the total of these balances is what
1,000.
what is the total of these two balances? It is 1,000.
Mm-hmm.
Let's say I want to transfer $200 from account 1 to account 2. I can do that. So what my balance should
Yeah.
be after that transaction? It will remain 800.
800
And
and
what will be
over
the
here
balance in the
200.
another account? It will be 200, right?
Mm-hmm.
I want to do one more transaction. I want to withdraw another $100 from this account, and I want to add $100 to account 2. Okay?
Okay.
What should be the balance of account 2 after this transaction?
It will be 300.
Correct. बट मेरे साथ ऐसा हुआ यहाँ पे कुछ फेलियर आ गया और यहाँ पे बैलेंस 200 ही रहा. Then what will be the total balance?
900.
900 is not equal to 1000.
Mm-hmm.
So this transaction will be cancelled. Okay?
Okay.
That is what we mean by consistency. Our database must remain in consistent state all the time. So we have defined this rule that the balance of account 1 plus account 2 must be equal to 1000 all the time.
Okay.
So that should hold true. Clear?
Yes.
Hmm?
Yes, Moki. Moki,
Yes.
you were saying
I
something?
see it. No.
Clear with this?
It's the consistency. Yeah.
Okay. So the third property is isolation. Let's say one transaction is happening. You are transferring some money from account 1 to account 2. It should not interfere with some other transaction. Okay?
Okay.
So write down in brackets no interference with other transactions. Write down in brackets no interference with other transactions. Isolation of exclusive locks. Let's see an example. Let's suppose we have three accounts, account 1, account 2 and account 3. The total balance in the book of a bank is 4,000. Okay?
Okay.
The summation of balances between account 1, account 2 and account 3 is 3,000. Let's suppose this is bank itself. So bank want to deduct $10 yearly charge from your bank account to let you use services of bank. Okay?
Mhm.
And right now you are making a transaction of $300 to account 2. So at that time there will be read and write lock on your account, also known as exclusive lock. Since the transaction that you are doing is gonna affect your balance, there should be exclusive lock on your account. And that transaction is also gonna change the balance of account 2. So there is a exclusive lock on account 2 also. So right now if the bank wants to make a transaction of $10 from your account, they want to deduct $10 from your account, it is not possible. Only and only after this transaction has successfully completed and the balance is written as 700 and 300, then only bank will be able to make a transaction of $10 from your account. These are two different transactions which should happen independent of each other. Okay?
Mm-hmm.
So that is called
Okay.
isolation. If if more than one transaction is happening at a time, all those transactions should be independent of each other.
Mm.
The fourth and last property, durability. If a transaction is completed, it should be robust. उसके
What does mean robust?
वही explain करने वाला हूँ. If there is some failure in databases after your transaction has happened and everything is committed, there is some technical failure, but then it doesn't mean that your balances should go invalid. Whatever is returned to the database should prevail. Even if the system itself restarts or shuts down, it will first write your changes to the hard disk and then it will do this activity. Meaning, whatever happens, we will be able to bring our database in a stable state again. Okay? That means
Okay.
durability. So Mirza, this is one important topic which is Very frequently asked. Let's talk about normalization. So let's say we have one table in which we have all the customer data. So it will go like this: ID, customer name, address, phone. Let's keep it short. So in ID you have 1, 2, 3, 4, 5 and so on. In customer name you have Kalpana, Chawla, AR Rahman, Amir Khan, Narendra Kumar, and Upvan Agrawal. Okay. Let's see, we have this column. So Mirza, looking at this column, if you want to mention any name again, we can do that, right?
Mm-hmm.
But let's say we are querying on the database again and again, and we are only interested in knowing limited information. Let's say I'm just interested in knowing the first name of that customer. Can I do that? Yes, I can do that using instr substr. But I have to perform some operations in order to achieve that, right?
Yeah.
So I am storing some redundant data in my database. I am repeating the information corresponding to a customer in the database again and again. Let's say I have a table student and I have 10 customers. All of them are having subject as science. So I have to write science corresponding to all 10 of them, right?
Mm-hmm.
And I could have assigned a single digit or single ID corresponding to them. But since my database is denormalized, I am bound to repeat the same data again and again. So in order to reduce this redundancy of data, we apply a methodology called normalization. It is a systematic approach of decomposing tables to eliminate data redundancy and undesired characteristics like insertion, updation, deletions. इनमें anomaly होगी, right? Suppose मुझे एक नया subject insert करना है mathematics. I can do that, right?
Yeah, you can do that. Uh-huh.
But that won't be depending on my primary key. So let's learn more about this approach of decomposing the tables and reducing redundancy. So we have first normal form, second normal form, and third normal form. So let's take the example that they have given only. Let's suppose we have this table: student ID, student name, student address, and subject opted. Okay. Now Adam corresponding to student ID 401 and Adam corresponding to student ID 404 are having addresses Noida, and they have opted subjects bio and physics. So first
Mm-hmm.
normal form, As per first normal form, no two rows of data should contain repeating groups of information. एडम ने बायोलॉजी और मैथ्स दोनों लिए, राइट?
Yeah.
अगर डेटा इस फॉर्म में होता, एडम ने दो सब्जेक्ट्स लिए हुए हैं, बायोलॉजी और मैथ्स, it should not be done like this. Data must not contain repeating groups of information. Each set of
Yeah.
column must have unique value. तो यहाँ पे बायोलॉजी और मैथ्स को डिवाइड करके हम एक और कॉलम बनाएंगे, that will be Adam with age 15 and subject maths. This is first normal form, Mirza. Okay?
Okay.
Now let's move ahead. Let's see, we have the same example. We have this table with Adam of age 15, Alex of age 14, Stuart of age 17, having subjects biology, maths, and maths. Okay? So right now, looking at this, what data are we having? We are having Adam, who is of age 15, having biology and mathematics, Alex of age 14, having mathematics, Stuart of age 17, having mathematics. So we can actually create a separate table, but we can actually have a separate table holding information about subjects. So that's what we are going to do in second normal form. As for second normal form, there must not be any partial dependency of any column on primary key. There should be full dependency on primary key. In this case, our primary key is Adam, the student name. So the age is fully dependent on Adam only, while the subject was not dependent on Adam at all. So we will create a separate table for subjects having subject ID and subject, and a connecting table between student and subject.
Okay.
So in third normal form, we are going to divide this table further, and we are going to have a separate table for subject, in which we will assign ID corresponding to subjects, and we will assign ID corresponding to each of the students. So the third normal form applies that every non-prime attribute of a table must be dependent on primary key. But in this case, it is not.
Okay.
So what we'll do, we'll have three tables, one for student details, one for joining student and subject, and one is for subjects. That's one example. We have another example over here. Let's suppose this is a table student details. So in this case, we are going to divide this student name into first name and last name. And we are going to divide, there is a possibility that there may be multiple people living in Little Rock, right? It is not necessary that there are only limited number of people living in Living Rock. It is also a possibility that there may be hundreds of people living on same street on which you are living right now, right?
Yeah.
So all of those people will have same address, correct?
Yeah.
Or at least the same zip code that you all will be sharing.
Sharing, yes.
So what we do in such cases, we assign each person a zip code only, and corresponding to that zip code, we hold address information in some other table. We do that, right? Our postal system is based on that. So that's what we are doing in this example. We are storing all the student details in a separate table and all the address details in a separate table, and one table in order to join the student table and address table, which will be having a student ID and zip code. Okay.
Okay.
So Mirza, these are very important topic, normalization of database. I'm also pinging you
So
this link.
so which excuse me, which normalization form
We go up
using
to
in
second normal form.
okay. Okay.
And if you want to normalize our database further, we go up to third normal form. Depends on our requirement. If we are working on a transactional or relational database model, we will go for normalizing the database. If you are working in a data warehouse, instead of normalizing a database, we focus on denormalizing it. So we have a huge fact table in case of data warehousing system, right?
Mhm. Your voice is breaking down. Upam.
Is it okay? Wait a moment. I think internet is good. Is it okay now?
Yeah, right now. Okay, good.
Okay. What we were talking about? Please remind me. मिर्जा रिमाइंड करवाओ मुझे किस बारे में बात कर रहे थे?
Okay. Again, your voice is breaking.
Oh God, one moment. I think it should be good now.
Yeah, it's good now.
It cannot get any better.
Okay.
Okay. Okay, Mirza, we were talking about data warehousing systems. So in relational database system, we focus on normalizing the data as much as we can. But
Uh-huh.
in case of reporting system or data warehousing system, we focus on denormalizing the data in order to avoid the joinings. अगर टेबल्स को बहुत
Yes.
ज्यादा नॉर्मलाइज कर दिया तो हमें उन्हें बार बार ज्वाइन करना पड़ेगा कोई भी डेटा
Uh-huh.
रिट्रीव करना है तो
Yeah.
जब डेटा वेयर हाउसिंग सिस्टम पे काम करेंगे तो नॉर्मलाइजेशन को कम्प्लीटली अवॉइड करेंगे
Uh-huh.
हम ट्राई करेंगे कि फैक्ट टेबल में हमारा सारा डेटा हो सारे डायमेंशन जितने भी डायमेंशन टेबल्स हैं उनके आईडीज हों और सारे फैक्ट्स हों फैक्ट टेबल में
Yes.
ओके ओके Mirza, so that's about normalization of databases. Can we move to another topic?
Yeah. Definitely.
Sure. Mokhi, you are comfortable?
Yeah, I'm
Also,
listening. That's all.
also have a okay, okay. So if you have any question, you can ask us. It's okay.
Yeah, I'm not going deep. I'm just listening.
Okay, fine.
That's, don't count me on that. If you count, yeah, then don't
Okay,
count me. I'm just listening, and then if I have any times like
fine, fine,
I'm
fine.
because
Okay,
just
no
gonna
problem.
take this one now. I have already some project going on. So it could be in the future project anytime if my project fails.
Oh, you just a moment. So let's discuss about analytical queries now. This is my table having four columns: ID, name, credit score, and status. Okay.
Mhm.
Now my requirement is I want to get the status for a customer when its credit score is highest. Mirza, I think that I should give it to you as an assignment after discussing analytical queries. Let's try to write a query for fetching out the status of a customer when its credit score is highest. Okay? So how many customers are we having? Jack, Mike, Sai, Kali, Afghan, Matt, Fiza, Hari, Labna. These 9 customers we are having. Okay? Let's see corresponding to Jack. The credit score is 10, 7, 8, 9, 4 and 10 again. Let me make it 8. Sorry. Just for the sake of improving the example. Not the 8. Let's make it something different. Let's make it 11. Okay? So Mirza, what is the highest value of credit score corresponding to Jack?
11.
11 is the highest value of credit score corresponding to Jack. What is the status of Jack? D.
D. Yes.
So that is what I am interested in. Similarly, corresponding to Mike, we have here the credit score 4, 7, 4, 8, 9, 3 and 5. Which one is the highest? 9 is the highest. So I am interested in this. And there is just one row corresponding to rest of them. So this will be my result set, right? So what we did here was, first we saw all the records corresponding to name Jack. That's what we did, right?
Yes.
Let me add a filter. So we are only interested in Jack for now. And then we ordered by credit score in descending manner. We were interested in finding out the largest. Correct? And we were interested in fetching out the status corresponding to Jack when the credit score corresponding to Jack was highest. So what is the status in that case?
D.
Right. What we can do here is we can assign row numbers corresponding to all the records that we have sorted till now. So I am assigning it 1, 2, 3, 4, 5 and 6. Okay.
Okay.
So we were interested in the result when row number corresponding to Jack was 1. Do you agree with me?
I'm sorry, say again.
We were interested in this status of Jack when the credit score of Jack was highest. Correct?
Yes.
Corresponding to the data set that we prepared, I've assigned a row number corresponding to each.
Yeah, row ID, okay.
I've just assigned a index corresponding to it, a running sequence. 1, 2, 3, 4, 5, 6. Okay?
Okay.
So if I'll say I'll get the record corresponding to Jack when row number equal to 1, I'll get this, and this is what I require. Correct?
Yes.
Now let's see corresponding to Mike. Corresponding to Mike, we have this record and we have this record. and this record and this record, clearing it out, removing the fold, how to remove the fold, leave it. So let's find out where we have mic. We have mic in these all columns, right? Okay.
Yeah.
So what are the credit scores corresponding to mic? 9, 8, 7, 5, 4, 4
4.
and 3. Let's say I am assigning the row number 1 to the highest credit score, 2 lower than that, 3 after that, and so on. I can do that, right?
Yeah.
Let's do the similar activity corresponding to Jack. That's it, no more Jack. Okay. Let's do the similar activity. No, here will come 4. Then this will be 5. This will be 6. Okay. Let's do similar activity corresponding to rest of them. One, we have more of Oscar.
No.
Okay.
Okay.
We did this activity corresponding to all of them. Now we are only interested in the records where row number is 1. We got our answer.
Yeah.
Let's match it with the previously copied result. Strong. Removing the filter. Let's see these two results. Let's order them on name. So the status corresponding to Jake is D. The status corresponding to Mike is U. The status corresponding to Sai is D. Okay. In both the cases, corresponding to Kali it's F, corresponding to Oscar it's G, Matt W, Fizar W, Hari E, and Lobna C. All the results that we got are matching, right?
No, it's not matching.
It is matching.
Oh, it is matching, but it, okay, it's a
That just the
different
sequence is different.
sequence. Yes, sequence difference. Yes.
Okay. What? Okay. This minus this. No, doesn't work this way. Now it is matching fully
Yeah.
when sorted.
Mm-hmm.
So Mirza, this functionality that we discussed just now is called row number. This is what happens in background. So first step is make partitions based on name. That's what we did, right?
Yeah.
We made partitions based on name. We saw all the records corresponding to Jack, and then we saw all the records corresponding to Mike, right?
Mm-hmm.
Second step is order by key attribute. Our key attribute here was credit score. Third step is assign row numbers corresponding to
Oh, I think the third step
each
was a status, right?
partition. That's fourth step. Fetch required information corresponding to Rn equal to 1. Now let me write a query for that. Let's suppose the name of this table was customer. Okay.
Okay.
Let me write a query for achieving this result. So the query goes like this. Select name, comma credit score, comma status, comma row number. Over partition by name. That's what we did. We partitioned on name, right?
Yeah.
Mirza, pay attention to this. This is very,
Yeah. That's what, like I'm.
very difficult, and not even experienced people are comfortable with this. So we are calculating row number over partition by name, order by. बताओ किससे order by किया था?
Order by the
Order
credit
by.
score.
Correct. Ascending or descending?
Descending.
Correct. Because we want the highest value first.
Yes.
So that's how we write a row number query or a standard analytical query. Okay. Okay, Mirza.
Yeah, but okay, I am still a little bit confused on about this query. Select name, credit score status. Okay.
Have a look at the steps also, the steps that I wrote. These are the steps. Make partitions based on name. Second step was order by key attribute. Third, assign row number corresponding to each partition. Fourth, fetch required information corresponding to Rn equal to 1. Now have a look at the query. We are interested in name, credit score and status from table
Select
customer.
name.
So we selected name, credit score and status from the result of this. So मिर्जा ये जो inner table बनी है ना, this one, ये जो inner table आप देख रहे हो ना, ब्रैकेट्स के अंदर, ये इनर टेबल मैंने आपको प्रैक्टिकली बना के बताया यहाँ पे.
No, but in this case, actually, I think you.
ध्यान से सुने, ये जो एक्सरसाइज हमने यहाँ पे की थी ना, यहाँ पे मैंने आपको वो इनर टेबल बना के बताया था. तो हमारा इनर टेबल ऐसा दिखाई देगा. If you will just run this, अगर आप ये क्वेरी रन करते हो ना, तो आपको ये रिजल्ट मिलेगा मिर्जा. This is the result that you are gonna get as a result of this query.
Okay.
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 And then we selected Rn equal to 1. So corresponding to Rn equal to 1, this is what we got. Corresponding to Rn equal to 1, this is what we got. Okay.
Okay.
And we were not interested in selecting all of them, so we just selected name, credit score and status. That's what we did in this query also.
Yeah.
I'll just press Control Z a couple of times.
So only one table, right, Upam?
What?
This is the only one table, right?
So Mirza, you can do this activity when you are doing a join also.
No,
we can do this activity. No, I didn't get your question.
My question is the table with the status, name, credit score, RN. It's only one table?
We are not selecting this row number from this table. We are generating this row number based on the calculation upon the attributes which are present in this table. आप यही पूछ रहे हो ना कि रो नंबर इस टेबल का पार्ट है क्या? रो नंबर इज नॉट ए पार्ट ऑफ दिस टेबल.
ओके ओके ओके.
फिर आप ये पूछ रहे हो कि मैंने ये नेम, क्रेडिट स्कोर और स्टेटस सिलेक्ट किया, ये कहां से सिलेक्ट किया? मैंने उसी टेबल में से सिलेक्ट किया क्या? तो इसका आंसर है ये मैंने टेबल में से नहीं, इस व्यू में से सिलेक्ट किया. जब मैं एक सब क्वेरी लिखता हूं तो इंटरनली एक व्यू बनाता हूं ना, उसमें से सिलेक्ट किया मैंने ये सारा इंफॉर्मेशन.
ओके.
और बताएं, और पूछें.
How about A, like a M from customer bracket end, then A? alias?
A is nothing but alias given to this subquery.
Okay, I got it.
I forgot to put from here. My bad. Okay, anything else?
No, that's all.
Okay. So Mirza, let's stop here.
Okay.
That's a lot for a day. And do practice this one, row number. Write it down. I'm giving you an assignment. Let's say I have a table student. In table student, I have student names and their marks. Okay?
Mm-hmm.
Okay. So Upman got 10 marks, Mirza got 6 marks, Naved got 9 marks, Amil got 5 marks, Jaya got 2 marks, Divya got 3 marks. Okay?
Okay.
So who is the student who has got the second highest marks? Naved is the student who got second highest marks, right?
Mm-hmm.
So I want you to find it out using a query having row numbers. ये जो row numbers हमने अभी पढ़ा ना, इसको use करके I want you to query on this table student, and I want you to find it out the student which has the second highest marks. Can you do that? Try that. अभी कहीं जा रहे हो मिर्जा?
No, no, no.
So बैठो इस पे 2-3 घंटे दो. It is not an easy one. And try to solve it. अपने डेटाबेस में ये टेबल बना लेना. डेटाबेस में टेबल बना के प्रैक्टिस करना. टेबल कैसे बनाओगे? Create table student bracket start name varchar 225 comma marks number 10 bracket close semicolon. टेबल बन गई. अब टेबल में डेटा इंसर्ट कर देना एक एक करके. ओपन मिर्जा नावेद मिल जाए दिव्या. And marks 10 6 9 5 2 3. So your aim is to find out the student which has the second highest marks.
Okay.
Don't take help from Google or you will find the solution there also. Okay मिर्जा, मैं आपके साथ ये वीडियो भी शेयर कर दूंगा और ये एक्सेल शीट भी शेयर कर दूंगा.
Yeah, okay.
Okay Mokhi, any question from you Mokhi?
No, yeah, I have a question. Like Mujia told me sometimes that you guys gonna teach the scripting, or is another person?
Which scripting? PL SQL scripting or the Unix scripting?
Both, or something like that.
First we are gonna cover SQL and Informatica, then we are gonna move to Unix scripting.
Okay, so now you are.
We don't need PL SQL.
Okay, so this course you are giving, this is for Informatica.
This is for ETL.
ETL.
This is for all the profiles related to